This is FE Peer Review. The date is January the 17th, 2022. Flat Earth Intel Corey Kell's 45-degree sector test is bogus. If you are planning to participate in, or more importantly, contribute financially to Corey Kell's 45-degree sector test, or to other work by flatearthintel.com, please take a few minutes to watch this video. Thank you. Corey Kell is the brains behind the flatearthintel.com website, and I assume also the owner of it. Corey Kell's 45-degree sector test, promoted on that website, is fundamentally flawed and effectively useless. I'll show why here, using a simple visual aid and nothing more than arithmetic. Even Kell will understand this, though I expect he will ignore it, as he has ignored my reviews in the past. Kell has shown he can talk for hours about his so-called test. He can make it all incredibly complicated and confusing, as demonstrated in this nearly 5-hour-long live stream. But it boils down to one simple claim. According to Kell, if you do a measurement of solar altitude 3 hours before or after noon, and if that measurement exceeds 45 degrees, this is impossible on a globe, and therefore the heliocentric model is wrong. The problem is, Kell is wrong. Solar altitude readings 3 hours before or after noon are entirely compatible with the heliocentric model. We will use this simple 3D tool to demonstrate that readings greater than 45 degrees are to be expected in the heliocentric model. Having demonstrated that Kell's essential premise for his 45-degree sector test is completely wrong, there's really no need to address all the other minor problems in that test. So we're now in a program called SketchUp, and I have created already a few items here, but I'll show you first. SketchUp organizes space on 3 axes, red, green, and blue, typically thought of as the X, the Y, and the Z axis, or Z axis, depending on where you're from. So what we're doing is we're creating a sphere around the origin point where the 3 axes meet. I've made the sphere already. That's our sphere. Just a simple ball. Could be a basketball, could be a golf ball. In this case, we're going to call it Earth. The next thing I've done is I've created control station. This is what a control station looks like. And first of all, I want to say about control stations. The terminology I'm using comes from the U.S. Army Corps of Engineers Control and Topographic Surveying Manual. This manual is available online. It's an official document of the U.S. Army Corps of Engineers, and it contains a glossary of surveying terms. One of my problems with Corey Kell's presentation is that he uses a lot of pseudo-military jargon. He makes up phrases and gives things names that have no solid reference base. Problem with that is that he can then define them however he wants and change definitions midstream if he decides it's convenient to do so, and he does. I would rather use the official terminology used by the U.S. Army rather than his terminology, which has no legitimate basis. So they're called control stations. And the point at the center of the control station, which represents the spot where the observer is, that's the control point. The station that I've made here has a line that goes from the control point to the center of the Earth, and then it continues in the opposite direction to indicate the zenith at the control point. The square simply gives us an easy visual reference to represent the tangent plane on which the observer is standing on the Earth, and then the crossed lines give us the 4 cardinal points. I've placed a control station at the top of our sphere here, which for the moment we can consider that the North Pole. And what I'm going to do, first of all, I'll get rid of this extra one here. We don't need it anymore. I'm going to make copies of this control station, rotate it about the center of the sphere, one at the equator, one at the Tropic of Cancer, and one at the latitude of Kabul. It's easier to rotate this control station if I turn Earth off for a moment, so I'll simply conceal it. Gets it out of the way so we can do our work here. This is our control station. We're going to rotate it around this axis, endpoint. And if you look at the bottom right corner of the screen, you see it says angle. As I rotate, I can type in 90 and get a precise 90-degree rotation. Now I'm going to repeat that process, and I'm going to rotate the one that's at the equator. I'm going to rotate a copy up from the equator. 23.43 degrees. Typed into the bottom corner, that gives us Tropic of Cancer. And I'll repeat that one more time, rotating 34.5 degrees, which gives us the location of Kabul, Afghanistan, 34.5. So those are our 4 station points: North Pole, Equator, Tropic of Cancer, Kabul, and they all lie on the same longitude. Now I'll turn Earth back on. We can see that they all converge at the center of the sphere, and that they all lie on the surface of the sphere. The next step is to take those and rotate them around this blue axis, the polar axis. Rotate them 45 degrees west and 45 degrees east, and that will give us station points representing a 3-hour rotation of the Earth. So again, I'm going to make a copy and rotate. This time I'm going to rotate around this central point up here. Zoom out so you can see what I'm doing. As you can see, I'm rotating a copy, and in the bottom corner it says angle, and I'm going to type in 45. And then I'm going to repeat that the other direction. 45. There we go. So now we have our station points nicely distributed across our sphere. We have a set facing solar noon and a set 3 hours to either side. Let's take a look top down. You can see that the North Pole here is at the intersection of these axes, and then we have a group of station points facing directly to the right along the red axis. That would be towards the sun, and then 45 degrees to either side. Before we rotate the Earth to do the axial tilt, I want to show you one thing here. On this red axis, that's the direction towards the sun. I've drawn a dashed line. You can see it there now. And this dashed line, right on the red axis, passes through the zenith of the control station at the equator. I'm going to add a few more of these dashed lines from the other control stations facing solar noon. So we now have lines representing solar rays passing through our control stations along the solar noon longitude line. You can see that they pass through that intersection there. And now we're going to rotate the entire Earth assembly, but not the solar rays, to account for the axial tilt of Earth's rotation relative to the orbital plane. So we're going to rotate it around this green axis. And again, you can see the amount of rotation in the bottom right corner. And you can see that as I rotate it, it's rotating around the center of the sphere. So I'll type in 23.43, enter, and there we have it. The Earth's axial tilt, representing summer in the northern hemisphere. And you will note that that solar ray that was passing through our equatorial control station is now passing through the zenith of our Tropic of Cancer control station right here. So this model here represents one specific day of the year. It represents the summer solstice of the northern hemisphere. Easy enough to alter this to use other days. The winter solstice would simply have the sun off to the upper left along the same parallel line. The equinoxes would be along the green axis, upper right to lower left would give us the equinoxes. And then it would just be a matter of rotating these sun rays to check other days. And then, of course, between those dates of solstices and equinoxes, they would be in between these lines. I don't think any of that's necessary at this point, basically, to refute or debunk Kell's test. It's only necessary to show that there is even just one place and one day and time on Earth, according to his criteria of 3 hours plus or minus, where you get a larger than 45-degree reading. And in fact, there are many. So we will look at one now. We have the North Pole up where I'm circling the mouse, the solar noon longitude line coming down from it, and then at 9 a.m. or 3 hours before solar noon, I should say, to be more precise, 3 hours before solar noon, this is our Kabul control station. And we see our zenith line, and the dashed line is the solar ray that is passing through that zenith line. I'm going to zoom out here, and you can see that it is parallel to the other solar ray and to the red axis. So what we need to determine now is the altitude, the solar altitude of that line. We will start by moving our view to a position that gives us more like the feeling we're standing in that spot. So that's our observer there. That's where we're measuring the sun ray, and that's the sun ray coming in from the upper right here, coming down to the ground. I have drawn a triangle here with the hypotenuse being along the sun ray, a base at the ground, and then a vertical measuring up. That gives us a simple visual cue for measuring solar altitude. As a brief reminder, solar altitude is the angle measured along the azimuth line from the path of the sun ray down to the horizon, the shortest angle to an unobstructed horizon. It can, if the horizon is obstructed, it can also be measured from the zenith down to the light ray, and then that angle subtracted from 90 degrees also gives the solar altitude angle. That is the angle we're measuring, and that is the only acceptable definition of solar altitude angle here. So I don't want to see angles measured from the sun down to some other point on the horizon, which will always be larger. So we've got our light ray coming to our observer point. Our azimuth is simply from north, the angle from north to our light ray. And in this case, you can see that it's slightly more than 90 degrees. It lies a little bit south of the eastern line here. We don't need to concern ourselves at the moment with what that angle is. All we're concerned about is whether or not the solar altitude angle exceeds 45 degrees. If it does, I have demonstrated that Corey Kell is wrong. So now we see a blue line here. I've drawn a blue line. This is a quick and easy way to measure angles in SketchUp. We're going to rotate that blue line, and if you look in the bottom corner, as I rotate that line, you'll see the angle of rotation. So the blue line is the line we're going to rotate. We're going to be rotating around the observer, the station point. That's our rotation point. I'm going to click on the edge that we're rotating, and I'm going to drag it up with my mouse. You'll see in the bottom right corner where it says angle, it currently says 45 degrees. As I move my mouse up, and it will snap to the hypotenuse of that triangle, it says 49.5 degrees. So that is the angle of solar altitude at Kabul at 3 hours before solar noon on the summer solstice, 49.5 degrees. This agrees with a number of other sources that have been looked at by others in other videos, including I Can Science That, and this also matches the observation that Corey Kell has done himself. Now, I want to repeat here the key point. What I have created in this model is an accurate representation of the heliocentric model. Very simply, the Earth is a sphere of a defined radius. It rotates around the Sun on what's called an orbital plane, and its axis is tilted 23.43 degrees from that orbital plane. So if Mr. Kell, if you want to argue against what we see here, you need to show that this model does not accurately represent the heliocentric model, and that means you need to present a heliocentric model. And we will then look at that and see if it accords with accepted scientific references. Corey Kell made a very specific claim, and this claim served as the entire basis for his 45-degree sector test. His claim was that if you do a solar altitude measurement 3 hours before or after noon, and if you obtain a measurement of greater than 45 degrees, this is simply irreconcilable or impossible in the heliocentric model. Now, that's his claim. He has done observations of more than 45 degrees, as have others. On that basis, he claims that the Earth cannot be a globe. As a reminder of what the heliocentric model is, I've just taken this little image off of a typical website. These are all over the internet, easy for anybody to find. It shows the Earth orbiting around the Sun on what's called the ecliptic plane, while rotating around its own axis, which is tilted relative to that ecliptic plane by 23.4 degrees. In a nutshell, that's all that matters, and that is perfectly reflected in the SketchUp model we've looked at today. As far as geometry goes, that's all we need. Everything beyond that is just icing on the cake. I have shown in this model I have made that I've precisely conformed to that description. We have the plane of the ecliptic, which is where the rays of the sunlight come into the Earth, parallel along that plane. And we have the orbital axis of the Earth tilted relative to that plane. All of that geometry incorporated into this model. We've done a sighting to Kabul. The sighting matches Kell's own observations and the observations of others, and it exceeds 45 degrees. And I have done nothing in this model except recreate the heliocentric model as it is commonly understood, correctly understood. So, Kell, you don't have a lot of options here. Really, I don't see any options except to try to argue that somehow my model, my SketchUp model, doesn't represent the heliocentric model. Now, you can't really do that without having your hands on this model, so I will be happy to make it available to you. Send me an email. Someone in your circle probably has SketchUp if you don't. You could then dissect it yourself and see that it is indeed an accurate representation of the heliocentric model. That's about the only path forward I see for you, other than doing what you should have done a long time ago, which is admit that you're wrong, which you're not going to do, though, because you are making money off of this. You are selling your fun little kits of specialized tools for measuring sun angles, which can be measured without your specialized tools. So you've got a financial incentive to keep this thing going. Globebusters certainly has a financial incentive to support you in this. It's money in their pocket as well. So are you going to do the right thing Or are you going to continue peddling your nonsense? I have a hunch you're going to continue peddling your nonsense. It's too bad. Particularly coming from an Army veteran. Well, folks, that's it. I think I've had enough of Corey Kell. I may come back and review some of his observations when I get my hands on the data, or I may not. I've already shown that his entire premise is flawed and his test is meaningless, so I don't really see the point. Hope you all enjoyed this. Wish you all a very nice day, and I'll see you again soon. Remember, click that like button, leave a comment. Bye-bye.